So I believe this is where we stopped last time in terms of this conditional property. In terms of that, we give you this item here, which is again, let A be an event that the first computer or draw, and let B be the second computer that draw, right? And again, we mentioned this, which is again, if we go into the storage room and we randomly pick one computer, what is the probability for A? What is the probability that the first computer draw is defected? Which is again, out of the 10 computer, there are 3 of them defected, which is to find this probability, we have 3 divided by 10, which is 0.3. And for probability of B, the B one, they ask you is, given this thing here, what is the probability, find the probability of B given A have already occurred? Meaning again, what is the probability of you go in and select a second computer that is defected, given one of the computer that you already taken out is already defected, right? Meaning again, you have to take something out first, which is that part A, which is the, again, to do this, which is we go in the second time, given that one of them already taken out, which is we only have 2 out of 9, which is again, this is what we have in terms that 0.32222. And again, what is the probability of A and B, meaning what is the probability of first event and the second event happen, which is you just take the 2 events and you multiply them together, which is part A and part B. And again, this is what we have, which is 0.066666666, which is 0.0667, right? So again, all these 2 items are dependent. They are not because they affect each other, because the probability of B is different, right? If the probability of B is 3/10, then they are independent. Because this thing here, they are dependent. They all depend on one another, right? So this is the last. This is the last thing we cover on Thursday. Okay. So before I mention this thing here, this is what we have is the at least one. Before we get to at least one, let me share you this one here. So before we get to the at least one portion, do you guys see that the review in section 4.4 on your screen?
Yes.
Okay. Okay. So again, let's take a look at this thing here. So let's take a look at the review part, right? So before we move to the at least one, this is the chart in your table, right? This is the 3 things that we have for now, which is again the N, the probability of N, the probability of all, L, and the probability of at least one. So again, at least one, we haven't done it yet. So probability of N and all, right? So if you see the probability of the all, you ask yourself 2 items, right? If you see the word all the 2 items, are they mutually exclusive or are they not mutually exclusive, right? If you say they are mutually exclusive, if you say yes, then again, all you need to do is, because they have nothing in common, that's why they are mutually exclusive, then all you need to do is find the first probability plus the second probability, we're done, right? If they are not mutually exclusive, meaning they do have something in common, if they do have something in common, you find the first probability plus the second one minus what they have in common. So again, those are the 2 different formulas that you have dealing with the word all. If you deal with the word and, you ask yourself, is the 2 events dependent or independent, right? In this case, are they dependent? If you say yes, if they are, sorry, not dependent. If they are independent, if you say yes, meaning again, the 2 items does not affect each other. And if it does not affect each other, all you do is you take the first probability, multiply by the second probability, we are done, right? If they are not independent, meaning they are dependent on each other, then again, you take the first probability, multiply by the conditional probability, meaning multiply to probability B, given that A is already taken out, okay? So again, this is the chart, and we will do this thing later, a little bit later. But again, let's take a look at this item here. Let's say that we give you, or on your homework, they give you this problem, right? They give you this information. And again, on your homework, they probably have part A, part B, part C, so on and so forth. So let's say that this one here, I have 7 problem, right? I have this table, which is, again, I have the age range of the student in my class, let's say, right? And again, in my class, I have a male and female, right? And the age range between 18 to 23, so on and so forth, right? My frequency distribution table here, just that this is horizontal instead of vertical, right? So again, my class is this, which is, again, the age range. And so looking at this thing here, one thing on Canvas, not Canvas, your Connect Math, if they give you this thing here, remember, we need to find the total of each group and the grand total of everything, right? So again, looking at this thing here, we want to add all of the male together. If you add all of the male together, we have 11 of them, right? 2 plus 2 plus 3 plus 1 plus 2 plus 1, right? You have 3, you have 11 of them. If you add the female, you have 19, which is, again, if you take the male and the female, we know that the total of every single one is 30, meaning in my class, I have 30 students, right? And again, if you add the 18 group, the 24 group, the 30, the 36, the 42, and the 48 group, those your number you have. And if you want to double check, you can take the 7 plus the 5 plus 7 plus 4 plus 3 plus 4. If those numbers equal to 30, then you are pretty much have the right number, right? Arithmetic, right? So this is what I told you guys last time is, first of all, one thing is to recognize that one person is selected at random. So again, looking at this thing here, you only select one person, okay? So one thing, like I mentioned, if you select one person, one item, one thing, then you don't do multiple times. And if you don't do multiple times, you do not multiply, okay? So in this case, they ask you, if you select one student at a time, one person at a time, or at random, find the probability of the following. Find the probability of that person is a male, which is, this thing is very, hopefully easy in the sense that you say, okay, how do we find the probability of a male, which is, do you agree that probability of male is I have 11 male over the total, which is over 30, right? Which is, again, probability male, which is, this is a simple probability. How many male do I have out of the total, which is 11 over 30, which is, I divide them to give me, again, in this case, I only give you 3 decimal places. Again, Connect Math will tell you how many decimal places they want it to be. Agree? So looking at this thing here, that's all we have, which is just a simple probability in this thing here, which is probability of a male. I have 11 male out of 30. That's what I have, right? Similarly, probability of a person in the age group of 42 to 47, which is in that age group, how many do I have? Which is in that age group, I have 3 out of the total, which is 3 out of 30, which is 0.1. Right? So again, those are the 2 items, or those are what I have in the sense that they are simple probability. The one thing that a lot of students get confused is they see this word and, right? And you say, wait a minute, Mr. Tran, last time you say that if I see the word and, I have to ask myself, is it independent or dependent, right? But in this case, remember, how many people am I selecting? I only select one person. Right? If I want to select one person, this and is not and then, right? This is the and also, okay? So you have to distinguish the word and then, which is I pick one and then I go back and pick the second one, right? In this case, I pick only one person. This and is I pick the person is a female, and also that person is in the age group of 42 and 42 to 47. Which is looking at this thing here, basically specifically in this age group, how many of them in this age group, how many of them are female, which is, do you agree that I have only one of them, female, out of 30 people in total, which is in this case, I have 0.033, right? So again, distinguish this word and, like I mentioned, is, again, the first thing is you want to ask yourself, or you have to ask yourself is, how many items, how many people am I selecting? If you select more than one, meaning you select multiple times. If it's you select multiple times, then you need to multiply. And that is where dependent and independent come in place. This one here, we select one person, then again, it's either simple probability, which is the 3 items we just did, or simple probability, and or a mutually exclusive or not mutually exclusive, right? So looking at this thing here, looking at number 4, the reason why that this is the way that they write this, then there's a simple probability, right? Find the probability that the person is under the age group of under the age of 36. So what does it mean under the age of 36? Meaning again, less than 36, right? 36 is not under 36, so we have to include the 35, the 29, and the 23. Meaning this 3 age group. Everybody see that this age group, this age group, this age group, those 3 age group. This 3 age group or the age group that is under the 30 is under the 36. Agree? So again, looking at this thing here, like I mentioned, this age group that we have, this age group that we have, and this age group, those are the age group that we have that is under the 36, which is again looking at that item. Do you agree that I have I did wrong? Maybe I was sorry. It's supposed to be 7 plus 7 plus 5, 19. It's supposed to be 19 over 30, not just 7. I did some editing. I think I delete what I needed. It's supposed to be 7 over 30 plus 5 over 30 plus 7 over 30. It's not just, it's supposed to be 19 over 30, okay, ladies and gentlemen. So probably under the age of 36 will be 19 over 30, and then you can divide that, which is 0.6 something. In that nature, not this one. This is incorrect. Question with this 3 item we have here. Any questions so far here? All right. If you don't have question, let's take a look at the next item, right? So the next item we have, as you can see,
I'm sorry, just one question. It has nothing to do with the lesson right now, because I was just doing the ProctorU and I'm scheduling a session for my midterm. I'm sorry, I'm just gonna, so when I go and after I set up the appointment and everything, do I log in to the website and then take the test?
Yes.
Okay, that's it.
On the day that you schedule, you log on ProctorU, and they will have that section. You click on that section at that time, and they will have someone guide you, and then you take it.
Okay, thank you.
So now looking at this thing here, which is again, like I mentioned to you guys, that looking at this item that we have, which is again, when you see this when you see this word "or," right? When you see this word "or," you ask yourself, well, is this a mutually exclusive event or not a mutually exclusive event? So how do we know if it's a mutually exclusive event or not a mutually exclusive event? Which is, again, this is the question, right? We select one person. What is the probability that we select that person in this age group or that person in this age group? Everybody see that the 2 age group that we have here, which is again, the total of this age group is 5 and the total of this age group is 3. So again, this is the question is, if I select one person, what is the probability in this age group or in this age group? Which is again, like I mentioned last time, do you agree that this 2 age group, you cannot have one particular person who are in the age group of 24 and also in the age group of 42? Meaning the 2, again, these 2 age group do not intersect each other. And if they are not intersect each other, they are independent, not independent, sorry. They are mutually exclusive. And if they are mutually exclusive, then all we need to do is find the probability of the first one, which is 5 over 30, plus the probability of the second one, which is 3 over 30, and we're done, because they do not have anything in common. And because of that, all we need to do is add them up, which is 8 over 30. Therefore, we have 0.267, right? So again, that's what we have in the sense of a mutually exclusive or not mutually exclusive here. Because of the two items, as you can see, because of the two items that you have, they do not cross each other. They do not intersect each other. That's why they are mutually exclusive. And as you can see, the next problem here, the difference between this problem, the difference between this thing here, which is the word "or" here, which is again, we have this age group of 24 to 29, and this age group of male, right? Because we are asking you for this two group, not age group, this two group, one age group between 24 to 29 and one group of a male, which is in this case, like I mentioned last time, in this case, we have someone or we have something in common, which is again, there are these two people that is in common. That's why we say that this is a mutually, not mutually exclusive, okay? So again, because these two people who is a male and also in this age group, that's why they have it. That's why we say that they are not mutually exclusive. And if they are not mutually exclusive, we need to find the first group, which is the 24 to 25, plus to the second group, which is the 11 over 30, and minus what they have in common, which is minus the 2 over 30, which is in this case, again, you have 14 over 30, which give you 0.467, okay? So again, looking at this thing here, first of all, question with the difference between 5 versus 6. Why 5? We just add them, and then we divide our result. And why do we 6? We add them, and then we subtract what they have in common. Any question with 5 and 6? Everybody see the difference between 5 and 6? All right. So again, if you don't have that question, if you look at number, let me erase all of this, right? If you look at number 7, number 7 is the same, right? In this, the reason the same is because if you look at this thing here, first of all, we see that we have the word "or" once again, the word "or," and again, what are the two groups that they ask us? The two groups they ask us is the female, right? We select one person. What is the property of a female, and or that person is between the age group of 48 to 53, which is again same idea goal. Looking at this thing here, we know that there are something in terms that there are 3 of them is in common. 3 of them is a female and also in the age group of 48 to 53, which is in that case, then all we need to do is again, we find the first group, which is 19 over 30. That's your female group, plus the 4 over 30, that is your 48 to 53 group, minus the 3, which is the specific female who is in that age group, which give us again 20 over 30. Therefore, this is what we have, which is again 20 over 30. If you divide that, you get 0.666666666 repeated, which is again, this is my answer for this item here. Question with the first thing here. Hopefully this is the second time you see this thing here. Hopefully you identified what is the simple probability versus what is the compound probability that relate to mutually exclusive event, which is the word "or." So question with this slide here.
Mr. Trent, I have a quick question.
Go ahead.
Do you have the like the type notes for the rest of the chapters like you did for 1, 2, and 3?
I will try to take a look at it, and I can post it up there, but it's just the same. I will try to see my note and I post it up there. But it's no, it's similar to this this handout. It's just that it's just in Word. But again, I can take a look at it and then post it for you. Yeah.
Okay, thanks.
One question about the mutual, what is it called? The
Mutually exclusive. Go ahead.
Yeah, mutually exclusive and the independent, because we get a question on that on the homework, and they don't show the graph. They don't give us a table like you'd give us here. And what I found out, I had to know that independent, I needed to know, like, we have to have a clearer meaning, because they say, for an example, like a question they gave is like a woman, and you have to, a woman, and then they say a sorority. Are they mutually exclusive or independent or neither? So there's a table, you just have to figure out if they're related or not, I guess.
Right. That example is pretty much is pretty much actually, can that lady also be a sorority, right? In the sense that that example is pretty much actually, okay, A, that is, you know, that woman, let's say that woman attend Delgado, and B, that woman is in the sorority, something like that, right? And then they ask you, is A independent from B, or is A mutually exclusive from B, right? That's the question.
Yeah.
Pretty much they ask you, can A and B happen at the same time? Meaning, can that lady, can that woman is attend Delgado and also a sorority, right? So if you say yes, then you can see that A and B is not mutually exclusive, because that lady can attend Delgado and also can be a sorority.
Okay, and another question, it's like that, and it said a man and then sorority.
Well, can the man join the sorority?
No.
No, right? So that will be mutually exclusive, right? Well, he is a man by himself, or a sorority is someone else, right? Meaning, again, he cannot join a sorority, so they are, that two events are mutually exclusive. Does that make sense?
Yeah.
Okay. Pretty much you have to ask yourself, is the first event, event A, can event A